one more thing we need to look at before we start moving into the algebra. We sort of reviewed how to do operations with positive and negative numbers, positive and negative fractions, some decimals. We don't really do decimals all that much. We talked about square rooting, and we've talked about a couple of geometry things. One big thing left to talk about is something called powers and exponents. And you guys should be familiar with exponents. Okay. But just so you understand, oops, I'm going to do that. Go away. Okay. Just going to make sure I'm still recording. Yeah. Okay. A power. What's the purpose of a power? It represents repeated multiplication. It's all about multiplying. What does a power look like? Well, it consists of two numbers. A bigger number, or a normally written number. I call it X just because it could represent any number. And then a little number up and to the right of it. That whole thing is called the power. Big number, the number that we're going to keep multiplying by itself by, that's what we call the base. And the little number up and to the right, that is what we call the exponent. That tells us how many times we multiply the big number by itself. So for example, if we have this power, and I'll talk about how to read it in just a second, or actually you tell me, how would you read that? How would you say this? There's different ways you can say it. Zara?
Why did you say like 5 times 5?
Okay, yes. That's how you would do it. How would you read it? Five to the power of 3. What's another way that you could possibly read this one with a little 3? 5 cubed, good. So that's how we would read this one, is we would say 5 to the power of 3 or 5 to the third power. So 5 to the power of 3. Or in this case, if the exponent is a 3, you can use the word cubed. So in this one, the 5 and the 3 together are the power. The 5 is what we're going to multiply by itself. That's the base. And the 3 tells us how many times to multiply the base by itself. That's the exponent. And so for 5 to the power of 3, or 5 to the third power, or 5 cubed, like Zara said, it means 5 times 5 times 5. So it means 5 times 5 times 5. How would you read the second one, this one?
2 to the power of 8.
Careful.
Oh, 8 to the power of 2.
8 to the power of 2. Or if the exponent is a 2, what's 8 squared. And what does it mean to do? What does it mean? 8 times 8. And then you get that answer. Something that I'm not sure if you guys know. Any power raised to the first or to the power of 1. So if I said 5 to the power of 1, what do you think that would be? Just 5, right? Because all you're doing is you're taking a 5. And you're not multiplying by itself because it's not telling you to. So a power with an exponent of 1 always equals the base. Okay. So now let's actually start doing some of these. So the first example, you're given multiplications or just a number, and you're asked to write it as a power. How would you write this as a power? 3 to the power of 6, correct? Because you're taking 3 and multiplying by itself 6 times. How would you do the second one? Sorry.
7 to the power of 1.
Right, because you're not doing anything with the 7. It's just 1 7 that's sitting. What if we were asked to go the other way? You're given a power. You're asked to write it as repeated multiplication, and standard form means just the answer. So what does this mean to do? 3 times itself 5 times. And so you probably need a calculator for this. There's a couple ways you can do this on the calculator. Okay, you can do 3 times 3 times 3 times 3 times 3 and get your answer. Okay, a lot of times on the calculator, you're going to see one of these 2 buttons. Depends on the calculator you have. You may have a button that looks like this, or it may be X to the Y. Or you may have a button that looks like a little hat. Both of these mean exponents. So if you have one of these, you would go 3, punch this, then 5, then equals. And you should get 243.
I have X to the 2.
That's just square. So, oh, this is the one. Yes. 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 And that gives us 243. What does the second one tell us to do?
7 times itself.
7 times itself 4 times. Obviously, we're going to need a calculator for this one, because this is going to be 49 times 49, which is be somewhere around 2,000 or something. Which again,
2,400.
2,400. Good. All right. So most of that should be reviewed for you. This is probably going to be a little new. Because remember the types of numbers we've been talking about since the beginning of the year. Positive and negative numbers, as well as positive and negative fractions. So what happens when we throw fractions in as the base? What happens when we throw negative numbers in? And what happens if there's parentheses and if there's not? Because that's important. What do you think this means to do? you've got -3 in parentheses. That means you gotta keep the negative and the 3 together. What are you asked to do with that -3? Finley? Times it by itself 4 times. So this means -3 times -3 times -3 times -3. Which is going to give us,
Negative 81.
you sure it's negative?
Oh,
Positive 81. And this is going to be, this is a potential problem if you do these on your calculator. Because I will do B first. Because B is a little different, isn't it? It doesn't have the parentheses. So what does that mean? It means do 3 times 3 times 3 times 3 first, and then put a negative on in the answer. You see the difference between the two. The parentheses matter. So this is actually going to be -81. You've got to watch out. Students often have a tough time getting a hold of this one. You'll get it. So like if I said this, what's that?
-25.
-25. What's this?
Positive 36.
Positive 36, right? Remember the difference. Now this one's got a couple negatives in it. Well, what does it mean? It means, okay, inside here, I do inside the parentheses first. So inside I'm going to do 3 times 3 times 3 times 3 times 3. 3 times 3 times 3 times 3. And then I'm going to put a negative on it. But this negative outside tells me I'm going to put another negative on it. So it actually works out to be positive 81. What about fractions? Well, if you're, yeah,
Brackets on that, not on the other one.
oh, because I kept the parentheses on this one because I wasn't finished the question yet. Here I was finished the question. That's fine. Okay. Remember when we did square roots? Like if I said this, remember I told you that it means the same thing as square root of 4 over the square root of 9? It's the same idea with this. This means take 3 and raise it to the third. And on the bottom, take 4 and raise it to the third. To get? To me, just the answer. I wouldn't expect you to show work on this. You don't have to. Or you could do it 3 over 4 times 3 over 4 times 3 over 4. What's the final answer?
27 over
27 over 64. Good. This next one, is it going to be positive or negative, the answer? Positive. Because the parentheses, remember, this is -1 over 7 times -1 over 7. And a negative times a negative gives us a positive, so it'll be 1 over 49. Don't worry, you get the hang of it. And this last one, notice the negative is outside. So this means I do 5 over 8 times 5 over 8, and then put the negative on that answer. So what's my final answer? Yeah. Negative 25 over 64. Okay? So these kind of questions that we see on this page will be new to you. Where we start throwing negatives and fractions in. Okay? And parentheses. You got to watch out for those. Okay.